Okay, so let's take a look at the next two graphs here that we have. Y equals 2 sine of 3x. Okay, that's the first one that we have on the left. Now, the amplitude, notice here is 2. Okay, the amplitude is 2. That refers to the absolute, basically, it's like the absolute value of the range, okay? The range here is going from -2 to +2, and as far as the amplitude goes, we're just worried about the absolute value of that. So it's 2. Okay, so notice here, amplitude is 2, and it's because this is how far we go, and this is how low we go on the sine curve. The frequency, okay, frequency, just think about the definition of the word frequency, how often or frequent something occurs. The frequency is 3, okay, and that's because you have 3 sine curves from 0 to 2 pi. We have 1, 2, 3, okay? So you have 3 full sine curves from 0 to 2 pi. 3 full sine curves from 0 to 2 pi. And that's where the frequency comes from. Okay, the next graph we have is y equals 3 sine of 4x. And it's the same thing here. Let's talk about amplitude. Amplitude is 3 because that's how high we are going on the y-axis, okay? And the frequency is 4 because we have 4 full sine curves from 0 to 2 pi. 1, 2, 3, and 4. Okay, here are your formulas. Okay, now this is the equation. When we have the equation written out as y equals a cosine of bx, or even if it was a sine of bx, okay? The a stands for the amplitude. Notice here that it's absolute value, okay? Absolute value. So whether that A is negative or positive, the amplitude is always going to be the positive value. The frequency is the B value. Okay, again, that's how many times you have that's either sine or cosine, full sine or full cosine curve going from 0 to 2 pi. And the period is a span of 1 cycle. Now, the period refers to how long it takes basically for you to get one full curve, whether it be for sine or for cosine. The way that we find that is we take 2 pi and we divide it by the frequency. Okay, take a look here. So we want to name the period for this problem. Amplitude and frequency. Okay, so the period what do we think the period is? Go back if you're not sure. 2 pi over frequency is how we get the period. Okay, 2 pi over the frequency. Let's pull out the amplitude and the frequency first. So the amplitude is 5. That's how high we go on the graph. And the frequency, again, is how many full curves we have from 0 to 2 pi. We got 1, 2, and 3. Again, notice that's what we have up here, okay? So to find the period, we're going to do 2 pi over the frequency, which is 3, and that is the period. And you can just rewrite that as 2 pi over 3. That's it. Okay, and that would be 1. So this is where 2 pi over 3 would be. 2 pi over 3 is right here, because that gives us the one full sine curve, okay? Okay, next, let's pull out the amplitude, frequency, and period. Now, notice from the equation, I know that the amplitude is 2/3. Okay, that means that this here is 2/3. This down here would be negative 2/3. The frequency is 4. Okay, that's because that's what I have here. And I can also count 1, 2, 3, 4. For the period, it's 2 pi over 4, which I can reduce to pi over 2. Again, the period means the span of one full curve. Okay, so one full curve, I'm going from 0, this would be one full curve, and this is equal to pi over 2. Okay. All right. So amplitude, frequency, period. Amplitude is 1/2. Again, we get that from the A value in the equation. So this would be 1/2. This would be negative 1/2. The frequency, 1, 2, 3. And the period is 2 pi over the frequency. Okay, so basically you're taking remember this is going from 0 to 2 pi, and what we're doing, since we have 3 full sine curves within that span, okay, that's why you're dividing by 3 to find out where we have just one full sine curve, okay? And that ends right here. So this is where we would find 2 pi over 3. Okay, so now that we have been able to identify the period, the amplitude, the frequency, given the function and given the graph, now what we're going to do is just look, using the graph, come up with the function, come up with the equation, okay? So first thing we want to identify is is this sine or is it cosine? How do we know the difference between the two? Well, the easiest way to tell the difference between the two is the sine curve always intersects the origin. Okay, it always starts at 0, 0. Whereas the cosine function will go through 1, or if it's negative, it'll go through negative 1. Okay, but sine always goes through 0. Again, remember that the sine of 0 degrees is 0. The cosine of 0 degrees is 1. So that's why it starts off like that. Okay, so I'm just going to start with the formula y equals a sine of bx. Okay, we know looking here that the amplitude is 1. Okay, and b, remember that b represents the frequency. How many sine curves do we have going from 0 to 2 pi? 1, 2, 3. Okay, so that means that the b value is 3, and that's x. And for the frequency, if we needed to come up with the frequency, remember it's 2 pi divided by the period. This should be period. The period is equal to 2 pi divided by the frequency. So 2 pi over 3. Okay, now, do we think this is sine or cosine? Is it going through the origin? No, it's starting here at negative 1. Okay, so we are going to find the cosine function. So this is y equals a times the cosine of bx. Now, given the fact that the amplitude is 1, okay, the amplitude is 1, but the a value in this case is going to be -1. And that's because it's starting here. Okay, that's why it's -1. Now we want to find the frequency. Remember, so let me just jot this down over here. A equals amplitude, B frequency. Okay. Again, we want to see how many cosine curves we have in between 0 and 2 pi. We have 1, 2. So this is 1, this is 2. So therefore B is 2. Okay. In this case, the period would be 2 pi divided by 2, which is simply pi. And notice here, this is where the new the new cosine curve starts. Okay, let's take a look at this one. The accompanying graph shows a trigonometric function. State an equation of this function. First question is cosine or sine. We know that since it's not going through 0, 0, it must be cosine. So start out with y equals a cosine of bx. The a value is going to be -2. Cosine, okay, and the b represents the frequency. How many cosine curves do we have going from 0 to 2 pi? Only 1, okay? So the b value is going to be 1. So cleaning this up, it's y equals -2 cosine of x. Okay, let's take a look here. Write an equation for the graph of the trigonometric function below. All right, is this a sine or a cosine curve? It's going through 0, so therefore it is sine. Y equals a sine of bx. Okay, we have -1 here, -2, -3, 2, 3. Okay, what is the a value? A value is going to be 3. Sine of bx. Now remember, this is pi here. Okay, so if we have one full sine curve going to pi, how many sine curves do you think we're going to have going to 2 pi? We're going to have one more. Okay, so the frequency then is 2x. So y equals 3 sine of 2x. Okay, and if we wanted to find the period, remember that would be 2 pi over 2, and the period is pi, which makes sense because we have one full sine curve going from 0 to pi. Okay, write the equation of the graph. So again, we need to identify whether this is sine or cosine. It is cosine because we are going, sorry, not cosine, we're sine because it's going through the origin. A sine of bx. Since it's going down first, it's going to, the a value is negative. Okay, -1 sine of, okay, now b is the frequency. How many full sine curves are we going to have? Notice this is only part of the sine curve. We have to extend it further, and it's going to wind up at 2 pi here. So because we have only one sine curve, the b value is 1. Cleaning this up here, we get -1 sine of x, or you could rewrite that as negative sine of x. I just want to go back 1 second to say, to make sure that, okay, this here needs to be negative. Okay, that needs to be negative because it's going down first before it goes up. Same thing here. This is going down before it goes back up, so that needs to be a negative sign. Okay, take a look here.